Today we're going to start chapter 2, which is all about the air we breathe and looking at what is air, how does air change from place to place, what are different impurities, what's bad about breathing dirty air and everything. I'm super excited about this because this is actually what my master's degree specialty is looking at the chemistry of air quality. So I might cheer sometimes during some of the information, and I'm sorry in advance. All right, so let's first look at section 2-1. So why do we actually breathe? So in chapter 1, we spent a bunch of time talking about cell phones and understanding how cell phones work and metals and all the chemistry behind that. Chapter 2, we're going to be talking about, okay, what is in air? What do we breathe? Why do we breathe? Why are we built the way that we are? And we're going to spend some time also talking about our atmosphere too and how our world is made up in atmospheric gases and things like that. Now, you, in the time that I just said that sentence, breathed probably like 6 times. You just breathe automatically. You don't even know that you do it. You do that thousands of times every single day. And even though you probably sometimes have to be told to breathe, like if you've ever fallen and knocked the breath out of your lungs or something like that, your body just takes care of breathing and cycling that different chemicals through your body. So you breathe more than 11,000 liters of air per day. And if you do any kind of physical activity like going upstairs or running or, I don't know, trying to track down that bear, you actually will breathe even more air. Now, we use the term respiration for that. So respiration is when we take in oxygen to help metabolize the food that we eat. And what happens is sugar and oxygen are transformed into carbon dioxide and water, and then we take that energy that is made available and we use it in our body to make our whole body processes work. So with each breath, we inhale air, we get oxygen, and we exhale carbon dioxide and a little bit of water into the atmosphere. Now, air is not a pure substance. It's actually a mixture. So when we were talking about homogeneous and heterogeneous mixtures before, one of the examples, of course, is air. It has physical interactions of 2 or more pure substances present in different variable amounts. Now, the main components of air are nitrogen, oxygen, argon, carbon dioxide, and water. Now, we just so happen to breathe out a little bit of carbon dioxide and water, right? And we breathe in oxygen. So it's a good thing that oxygen, carbon dioxide, and water are part of air quality. All right, let's take a second to talk about how those different chemicals got into our atmosphere. So our atmosphere essentially developed kind of over 3 stages. In the very first stage of atmosphere development, there were a lot of really light and fast substances like hydrogen gas and helium gas. And as you had formation of the atmosphere, you saw the development of hydrogen and helium into more complicated compounds and structures. In the second stage of the Earth's atmospheric development, there was a lot of volcanoes that would spew out water and ammonia and carbon dioxide. Now, you have ammonia, water, carbon dioxide mixing in with a little bit of hydrogen and helium that were still there as you're seeing development of the atmosphere. You're starting to see chemical interactions working together, and you're seeing some chemical changes, which then led to development of new compounds that were more carbon-based through photosynthesis. So as organisms took in carbon dioxide and released oxygen, other animals would take in oxygen and release carbon dioxide. So you would have photosynthesis happening where you'd have plants that would be taking up carbon dioxide and putting out oxygen, and then animals, for the most part, would be taking up the oxygen and putting out carbon dioxide. And you get this really great balance. And then through the use of sunlight, because, we have this giant sun, a lot of the ammonia in the air is transformed into nitrogen and hydrogen gases. So the ammonia, which is NH3, starts breaking down into N2 and H2. And then the lighter hydrogen kind of drifts up into the atmosphere and into space, and the nitrogen kind of sticks around lower. So because of this kind of almost layered formation, we actually get a multi-layered atmosphere. So the multi-layered atmosphere looks like this. At the bottom level, where people live, you have the troposphere. At the next layer up, you have the stratosphere, the mesosphere, the thermosphere, and the exosphere. So this is an incredibly important graphic in environmental science, and let's look at it in more in detail and explain it. So this bottom level is the troposphere. This is where we live, and plants and animals and buildings are built here in the troposphere. In fact, the troposphere is 75% of the mass of the entire atmosphere. Up above the troposphere, you'll see it's the stratosphere. This is where the ozone layer is. And we're going to talk about that later, but the ozone layer helps protect us from the sun's rays. Above here, you have the mesosphere. This is where, when we have shooting stars that enter our atmosphere, this is where they burn up and make those really beautiful shooting stars. Above the mesosphere, we have the thermosphere. So this is where satellites exist. And then, of course, on the very edge, we've got this exosphere. This is incredibly thin. There's hardly anything up there, and it's very, very hot because it's close to the sun. So if you look at the troposphere, you start here at 0, you get colder to the stratosphere. The stratosphere warms up just a little bit. Mesosphere cools down quite a bit, and then the thermosphere gets hotter, 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 hotter because there's less molecules doing interactions and you're closer to the sun. So when we're talking about the troposphere and what we're breathing, here's a breakdown of pretty much what's in every single breath. So you have about 78% of what you're breathing in is nitrogen, and about 21% is oxygen, 0.9% is argon, 0.04% is carbon dioxide, and then there's this teeny tiny bit of water. So that's when you're breathing in. When you breathe out, well, your body doesn't need the nitrogen, so it breathes out all the nitrogen. But you also breathe out a little bit of oxygen. 16% of it is oxygen. That 0.9% is argon because your body's like, whatever, we don't need it. And then 4% of it is carbon dioxide. So we also breathe out some of that oxygen in the form of carbon dioxide. And then, of course, different people have different amounts of water vapor in your breath. So what you're breathing and where you're breathing is obviously very important in the atmosphere. And it really will be affected by, like, if you're standing next to a bunch of photosynthesizing plants versus if you were hanging out inside an apartment complex building or something where you've got a lot of recycled air. So that was the end of sections 2.1 and 2.2.